Hello and welcome to the Sovereign Boot Wizard demo. This demo is presenting the current state of development of Sovereign Boot Wizard, which is an application that simplifies the secure boot configuration on regular consumer UEFI systems. So we will be presenting the Sovereign Boot Wizard mechanics, features that are currently present and developed on an example of QEMU-x86 emulation machine with the share firmware. So, as Sovereign Boot is a feature that extends the UEFI Secure Boot, it can be found in the Secure Boot configuration menu. By default, the system boots with Sovereign Boot enabled and its state is unprovisioned. In this state, on each boot, the Sovereign Boot Wizard will be launching before any boot option is attempted. This aims to allow the user to firstly configure the trusted keys before booting any image. We can also boot the Sovereign Boot Wizard from the menu itself if the option is enabled. But let's start from the beginning. I will reset the system to show you how Sovereign Boot Wizard boots on the initial system startup. So here you can see that the Sovereign Boot is presented to us and welcomes us with the window that explains why it even has booted. Because we have been booting the system for the first time, the wizard will assist us in setting up the secure boot feature and will ask us to select one of the available modes. Right now we have two available modes, which is the Sovereign Boot, where the user decides which keys they would like to trust or do not trust. No keys are initially trusted by default, so it wipes out any existing keys that are already enrolled in the system settings. And of course, it requires a Sovereign Boot compatible operating system, which means that the images, the bootloaders of the operating system, have to be signed by keys that do not belong to Microsoft. You can also choose a standard secure boot with Microsoft certificates, where the trust is given to the default firmware keys. It is compatible with common operating systems that currently support Secure Boot, so Windows and Linux distributions using the shim. We can also exit the Sovereign Boot Wizard application if we are not yet ready to decide what to do. Upon exit, we will be landed inside the the firmware setup application. So let's talk a little bit more about the Sovereign Boot Wizard state. As I mentioned earlier, it is set to be unprovisioned by default. In this state, Sovereign Boot Wizard will launch on every system boot up until it is provisioned. So by provisioned, we should understand that user has enrolled the trusted keys into the secure boot variables. So in order to do so, the user will have to select the Sovereign Boot in the welcome window. When that happens, the user is presented the bootloaders that have been detected on the system. It is shown the description of the boot option, its hardware path, where the disk resides, where the bootloader has been found, and the file path on the disk itself. In future phases of the project, the wizard will also parse the images and look for embedded certificates. If any is found, a key fingerprint will be shown on the screen as well. Then the user will have to choose whether to trust this key or image and continue booting, or whether they want something else. By default, the highlighted option is Do Not Trust, and the, the wizard will simply proceed to the next detected key or bootloader. We can also trust this key or image and directly boot it. We can also trust this key, but if you want to analyze other boot options, we can also choose this button, and the sovereign boot wizard will simply proceed to the next bootloader and ask us to make another decision. If you are not sure, you can also show additional key certificate details that will help to make a decision. This option, however, is not yet implemented, as certificate and key support will be added in the next phase. We can also exit from this menu if you want to prematurely finish the wizard, or we just ended up here by mistake. But let's assume I want to trust this image and proceed to the next one, but I do not want to trust this one, so I will just do not. And it happens that we have only 2 boot options right now, so the wizard did not found any more bootloaders, and we are presented with an information window that no more bootloaders has been found. After pressing enter, we will be moved to a new screen, which is supposed to explain that our sovereign boot is already provisioned, and in the future there will be more options here that will help you augment or modify the settings of sovereign boot and secure boot itself. Okay, right now this is when it comes to the capabilities of sovereign boot wizard application itself. Now we will go back to the UEFI setup menu, and I will explain the mechanics and integration into the host firmware image and how the sovereign boot wizard influences the boot process. So, as I said, by default the system is unprovisioned, right? But what happens if we try to, for example, transition the system to the provisioned state? This is currently not possible at the current stage of development, so I will use the UEFI shell to internally change the state of sovereign boot to emulate a provisioned system. So I have a shell on a mounted image, disk image, and now I will simply modify the internal variable holding the state of the sovereign boot, and now we should be seeing a system that is provisioned. So what it means, we right now emulated that we have established the trust with the system firmware, and all our trusted keys are already there. So now system in this state will not show us the boot wizard on every boot, because we have already established the trust, so it doesn't have to launch on every system startup. And right now we'll be simply prompted to either enter setup or enter boot manager menu or whatever typically is used in the firmware. Alright, and that's the part about the default behavior during system startup. And now let's try to actually enable the secure boot, and we'll see what happens then. So once the secure boot is enabled, it means that any image will be subject to verification by the secure boot feature. So if a verification fails, the system firmware is designed to boot to the sovereign boot wizard just to indicate a malicious attempt to boot an untrusted image happened. As you can see, the sovereign boot wizard presents us with this window because we are attempted to boot an untrusted or unverified image. So we are presented a similar window than in the provisioning process, but with slight modifications. The sovereign boot wizard will just display this one bootloader that we just attempted to boot, and we have a slightly limited option. So we can either do not trust this image, and the system will simply the wizard will simply exit and the firmware will attempt to boot the next boot option in the order, or we can just say to trust this image or key and boot it anyways. As usual, we can also show the key certificate details. Let's say I will not trust. Or yes, and now we have the next boot option. Once we exit, we are presented that we could not boot the SHA-2 suite, which was the first boot option. So we can press the key and continue. Now the system firmware will attempt to boot the next boot option. And again, we are presented with this window. So let's exit for now because it's not fully implemented yet. And now we have the second boot option, which is QEMU hard disk, which also failed to boot because it is unsigned. And since no more boot options has been found, we are simply prompted to press any key to enter the setup. Alright, so we have the mechanics when one attempts to boot an untrusted image. Now we'll cover the interactions with the system firmware setup. Since sovereign boot basically depends on the configuration of secure boot variables, so the trusted signature database and forbidden signature database, any reset or removal of those databases will result in transition of the sovereign boot state to unprovisioned. So let's, for example, reset the keys to defaults. Yes. And it will cause the system to enroll the default settings. Since the defaults has been restored, the sovereign boot wizard state has had to transition to unprovisioned state. So we will be back to the behavior I have shown you during the startup. Okay, let's disable Secure Boot for now and let's go back to the provisioned state to show you the integration with the Secure Boot keys removal. Okay, system is unprovisioned, so we are back in the wizard during the initial boot up because it will not let us boot anything before we can establish the trust relationships. Alright, so now let's boot to the UEFI shell and emulate the provision state again. And now I will attempt to simply remove the secure boot keys. So removal of those keys will also remove the trusted key setup that we already made with the sovereign boot wizard. So it also will cause to transition to the unprovisioned state. And now we can see it's no longer provisioned. So whenever we boot the system again, it will cause the sovereign boot wizard to pop up. And yes, we have landed in the sovereign boot wizard once again. Now let's try to show you what happens when the sovereign boot is actually disabled. So let's disable the sovereign boot. And of course, disabling the sovereign boot, it means that we no longer want to use sovereign boot. So disabling this option will cause to restore the default secure boot keys and databases. And as you can see, the secure boot has been enabled back again because we enrolled all the keys from the defaults. So now when we reset the option, we will not be presented the sovereign boot wizard on the system startup. However, the secure boot is still enabled, so the verification of the images will work. And as you can see, there is no wizard, and once we attempt to boot an unsigned option, we are not presented with the wizard again. So it is like there was no wizard in the boot flow at all right now. And yes, we have two unsigned options, so we cannot boot anything. So we'll be just back to the setup. And once again, we can enable back the sovereign boot or just simply restore the default settings. It will be essentially the same. And yes, now once we enable the sovereign boot, we will be presented with the wizard once again. And as expected, we have the sovereign boot wizard enabled. So now, let's try to show you the integration with restoring the default system settings. So I will disable the Secure Boot to enter the shell and emulate the provision state again. All right. And now, all right, we have the sovereign boot provision state. So when I press the F9 key, the provision state should be transitioned to no, because restoring the defaults will also may also change how the secure boot settings work. So you have to reprovision the system with the trusted key again. So now let's reset after restoring the defaults. And we will be presented with the secure boot wizard again. And again, it shows us that we are booting for the first time. Either we restored the default system settings. And that concludes our current integration of sovereign boot into the share of firmware. Thank you.